good, because I bet that it'll be the year-length desktop and the JaxLug and Zoom.
Yeah,
So.
We've been foretelling this event for the last 15 years.
We keep saying we'll win the Super Bowl too, so it's gonna happen eventually.
Just gonna keep telling you.
So, I'm Dan Bidleman, your presenter tonight. I am currently the JaxLug president. I've been part of JaxLug since about 2006. My favorite distribution is right now it's Debian again. I keep going back to that. So.
Oh yeah.
I use Red Hat, CentOS, and Oracle Linux at my job, and systems administrator professionally. What's that?
You have a love-hate relationship with Arch.
Yeah, I like hate. I love Arch, but I hate Arch because they do things that break the entire environment. Like removing bin or static linking.
It was a very bold choice.
Especially right in the middle of your distribution wave. So yeah, but I enjoy playing with a bunch of distros. I play with like Gen 2, I play with Arch, I play with Debian. It's whatever I'm feeling. Today's presentation is on PortaPi Router. It's a PortaPi. It'll fit in your pocket, and I actually brought one of my other Pis because you could build it smaller. The way that I built this one is this is a Raspberry Pi 3. I assume we're recording, right?
Yeah.
So this is a Raspberry Pi 3. This has wireless on board. Now, from my testing, as you can see right here on the pings, I don't think the wireless on this is great. So it might be an enhancement to this project to put 2 external keys for the wireless, as opposed to just using an internal one and then an external one as well. So I'll experiment with that further and put it up on the page. This is just my personal wiki that I'll link to it off of our wiki. But right now what this guy is doing is it runs the wireless on board to connect to the wireless in this room. I use a WPA socket for that. And then a bridge is created between the physical Ethernet and this little dongle. That bridge is the internal network. And I'll show you how all that's set up and all the services that are done. But what you would use this for, you have a couple of use cases really. One, you want a private network in a public place. Let's say you go downtown, you have a couple of friends or coworkers you're working with, and you don't want to have to sit there and deal with a couple of different, like everybody's trying to hit that network, and then the network is kind of unreliable because there's a whole bunch of people connecting to it, and then if you're having like security issues because you're just literally jumping directly onto somebody's open wireless access point, that's not great. It's no bueno. So having a private network in a public place is fantastic. Provides you a firewall to your devices, so you can build your firewall here, really engineer it down to where it's like I know exactly what I want to let in, what I don't want to let out, all this kind of stuff. And you carry it around in your pocket. The ability to do VPN. Now this was mentioned on the list, and I didn't have time to include that in the presentation, but I will cover that again later on. Maybe we'll do a CLC on how to build a VPN for routers. But you can put a VPN on this so it connects automatically to some kind of wireless. Then if VPN tunnels out, and then you trunk all of the traffic that goes into this thing through that VPN tunnel to your endpoint. And so you're protecting all of your information that's going over this device from where you're at to that end of that VPN tunnel. If you're at a hotel, this is another point that's going to go. I've tried to do this before. Chromecast, right? Or a little Amazon TV. They're little devices, and you link them with your phone, and you tell like, hey, here's the access point password. Well, it has no ability to get through like one of those splash pages that a hotel might put up. Yellow Captain portal. You just can't do it. Like it just doesn't have that ability to do. They'll connect to the wireless, but they have no idea how to get through that Captain portal. This prevents that. You get this thing through the Captain portal because you just connect to it with your laptop, and then it gives your laptop the Captain portal, and then records the MAC address of this guy. And now all of your devices are able to get out. So if you want to push through the Captain portal on a Chromecast or something, you can do it. And then having local services. So like, let's say you have an impromptu LAN party with a whole bunch of people, and you want an IRC server or a couple of different services, or you have some images on here you want to serve out to everybody. Like if we're having a lug LAN, and we wanted to have where you could boot off the network. You do that. So I just set it down on the table. Well, there you go, LAN party. Right in your pocket. So great little device for that. You can even make it small. This is a Raspberry Pi Zero wireless.
That's got a little deal.
Yeah, I got a little case on it. And this is less powerful than this one. So it's not going to be performance. But if you're just accessing the internet and you're not doing huge loads and stuff over it, this will do just fine. You can power with a small battery too, so that's an advantage. Now, this is the 5,000 milliamp hour 2-volt battery. And I was able to power this and get into it. But as soon as I started trying to load through it, it failed. So the Pi 3 really needs that 2.4 amp. It can't be trunking it down to 2 amps for it to do this.
2 volts?
2 amps.
It's 5 volts at 2 amps.
Yeah, 5 volts, 2 amps. So this is 5 volts, 2 amps. This is 5 volts, 2.4 amps. And then I have another one that's bigger. That's 5 volt, 4 amps, but it can only do 2.4 per volt. The other thing I forgot to grab out the backpack is you can actually put this into the switch too. And so this switch, this TrinNet switch, if you read the bottom of it, it says power input is 5 volts, 1 amp. This little battery pack just happens to have a 2.4 amp and 1 amp. And so if I didn't want to have only wireless, I could just sit here, plug this thing in with just a dongle, and then you're ready for recording. Yeah. You just take the left and the cable.
I thought that was a good question.
And you plug the little Ethernet cable in there. And now, you go in. You can plug right into it, use Ethernet.
What's that called? TrinNet?
This is just a little TrinNet switch. It runs off of 5 volts. I actually put this in the hardware use. So in the hardware use, I'm listing every single piece of hardware I am using and why. So down here, so you have the NICs, and so this one is a small one, it's nano, very small antenna. So the range is very, very small. So you can probably use it in this room pretty much okay, but you go to the next room, it's going to be like, kind of shoddy. Whereas if you use the other one I put up there, the TP link, I'm sure you're going to be able to see the difference in antenna size. It has a lot better range. So you can use either one of these. These both, and I put the specific model numbers, they both have excellent Linux support. And they both are able to spawn access points because you're not 100% able to spawn access points on every piece of hardware. It has to have support for that particular mode of an access point to become an access point. So that's what we're kind of dealing with here. And I will start going over how to build one. So are there any questions up to this point on what, like, the hardware we're using, any kind of thing like that?
So the wireless dongle that you plugged in, that was into the USB slot? On the pot, huh?
Yeah. So it's just sitting right in the USB slot. I could put this in the same thing. And what's real fun is, I don't need to go down the backpack, but during the hurricane, my power went out, and my Comcast kept going for another 4 hours or so. I took this project box, I added another Ethernet port, I plugged this Ethernet port into my modem, I plugged the other Ethernet port into my PoE switch, I powered all of it, I powered this guy off the battery, I powered the PoE switch off of one of my UPSs, and I was able to stream my camera feed from the front of the house out to the internet for another couple of hours until it finally, until the network comes. And that was because Comcast ran out of probably battery power on the day. So you can use this as a little, like, get you out of the jail box where you're out of power or there's something wrong. You can engineer it to do this, and once you understand the routing fundamentals and how things are kind of linked into each other, you can start playing with it. So as I have it right now, it's only connecting to wireless using its internal card and then spawning an access point and using the physical Ethernet as its client area. And you can switch all that around. Right? You want to use the internal as the client area, and you want to plug into the, straight into the modem. You can do that too. You just have to mess with your routing tables and do different things like that. So it's very flexible. That's what's great about building a server to have as a route. You can do anything. And I can put services on this too, so there's lots possible. It's a very powerful piece of hardware too. For the Pi 3 is a quad core. I believe it has a gig of memory. I'm not sure if it's 5 volt per gig. It's a gig. Okay, so it's got a gig of memory. It's got a quad core processor. All right, it's an ARM processor. I think it's 1.2 gigahertz, which is amazing. All right, so $35, great. And I've had a lot of people say they love these cases. It's the same brand of case on both of those guys. It's just a zebra case, in case anybody wanted to know. You can go on Amazon. I think this one was like $5. $10 or $12, so it's kind of expensive. You put them together.
It's not your hardware used.
What's that? It's not my hardware use, no. Now you gotta watch the video to get all that.
Now, can you make your projector the size of that?
There's one called a Cube.
Yes.
You have one.
Big monster.
No, just has one.
Just that.
Yeah.
What's the beards?
So software is used. I'm using Raspbian Lite. Raspbian. There's two versions of Raspbian. There's Raspbian Full, Raspbian Lite. Raspbian Lite has just the operating system, but it's a very slimmed down distribution. So it's got a lot of tools and stuff in it, but it doesn't have like the GUI or anything like that. So you're running very low power. If you wanted to install a GUI on this, you can use the Raspbian Full image. But because you're using more processing power, this will use more energy and it will reduce your life on your battery. And so if you're doing it for something that's like a portable router, where you want to carry it around and you're going to carry it around with a battery, you want to bring the power usage as low as possible. There's all kinds of tips and tricks you can do with reducing the power footprint with the Pi as well, like turning off things you don't use. So like the Bluetooth is probably still on this. You can turn off the Bluetooth unless you want to use that as an interface. You can turn off the LEDs. You can do all kinds of neat things. You can actually with this one, I have it where the graphics are actually turned, the memory is all into the system. But yes, you can turn off the graphics chipset. You can fiddle with all this stuff. You can actually underclock it too. You can bring the processor clock down so it uses even less power. So there's all kinds of cool things you can do.
I got two things that just made me think of something. I was just in BJ's. They got micro SD cards, 128K, excuse me, gigabytes, $34. It's a SanDisk. Will it accept that? Much memory?
I actually go over that in the hardware section, I believe. Yeah. So I'm using the SanDisk Ultra 32 gig. The SanDisk Ultra or Extreme cards have error correcting. So they have a section of the card that is dedicated to when bad blocks appear, it just starts using those other sections of the card. So they will live with it. The cards will only last for so long because there's a finite number of reads and writes. When you're putting a file system on them, especially a file system that does journaling, it will read and write to that thing twice for every write. So it's the writes that kill us, not the reads. You can read from them all day long, it's fine. But the writes is a finite number of writes before it goes back. So I've had excellent usage of Ultra or Extreme SanDisks. I've had a whole bunch of other ones. I've had Amazon ones. I've had the Kingston ones are all right. I've had Amazon ones. I think PMI ones. there's a bunch of different ones that I've used, and they've all died. They've all had all kinds of problems. They start losing files, they start having corruption, or it just stops working. These things are solid. So if you can get an Ultra or an Extreme, or the Pro version, whatever that, they're great.
Can't tell you how many SD cards and thumb drives, if you boot off a thumb drive, you'll burn through it in 6 months.
Yeah.
It's crazy.
Yeah. And so getting a quality piece of, especially if you're going to build a project like this where you're going to roll line on and you want it to work, spend the extra $5 and go and get one of these. Because I'll tell you what, a 32 gig SanDisk, I think they cost maybe $15.
Can you get them that small anymore?
Yeah, I mean, it's kind of hard to find them, but yeah, you can get them in, I think you can get them all the way up to like, I think it's 256 gigs now.
I was saying, can you get them that small one?
Yeah, well, yeah, 32 is short. 8s are probably a little bit, I think 8 is the bottom, maybe 16 is the bottom now. But,
Could you, no, I guess you couldn't format a 32 gig and leave some unformatted space. It won't use that for.
No, it's
Yeah.
hard to line up to use that. So, first what we'll do is we'll go through the image deployment. Image deployment, it's a very basic thing. If this is going to be great for the new guys. What you do is you go and you grab an image. Right? So you go to the Raspbian site. Actually, that's funny. I don't think I actually linked the Raspbian site for Linux. I just did it for Windows. Oh wait, this is how to do the imaging steps. Was that? What? Yeah, it's these two. What I did here is I built a process for Linux, but then I linked to their process for Windows and a process for Mac. And so if you want to do this and you don't have a Linux box, you can reference these materials. So these materials are basically doing what I'm showing you on the application. So you go and grab the image. You download whatever image that you want, but I chose Raspbian Light in this case. And I use BitTorrent to grab it and pull it down. You always have like BitTorrent or HTTP or FTP links, or rsync it if you really want to. There's a bunch of ways to grab it, but you just go to Raspbian. And being that this thing's being lossy, let's see. I'm on the guest, but I think the wireless in this thing is choking a little bit because it fails to hang it out. Like I have no problems between me and it, but between it and my corporate at work when I was playing with it, and during lunch, and between this and the access point here, it's kind of shoddy. So I'm thinking that here it goes. So it works. But it's got loss and it's got a little bit of issues. I'm going to test that further and I'll update the wiki to like what I find with that. But yeah, you just go to the Raspbian download page here. Eventually it'll come up.
Google's ever going to put an ad while you're waiting for it to load.
Well, that takes time to load too.
And I think Microsoft is working.
So you have these different images, and this is Stretch with the desktop, and this is Stretch Lite this is the one I use down here. So Stretch Lite. You can grab it with the torrent, or you can just download the zip straight up. And so this is probably like an HTTP link, and this is a torrent file, which you would use something like Daily or something else to grab that. You can download for bandwidth concerns. What's that?
What do you mean by Stretch? Is it the name or?
Stretch is the version of Debian.
Oh.
So I believe
Yeah,
that's
a code.
I think
Right.
it's Debian.
Yeah, since I don't live in Denver.
Well, oh yeah, Stretch is just Stretch and Buster are on. It's a dual release. It's weird. So yeah, so this is Debian 9. And it's great distribution. So you need to grab a micro SD and a reader. I'm sure you know what a reader looks like. And make sure that you are okay with destroying all the data on the micro SD make sure that you guys know when you're doing this, especially in like Linux and stuff, these are all done as root, okay? Your fdisk-out will just show you the partition layout, so I was just showing you before and after here. But this command is destructive. So if you go and you put your root drive here, your operating system is gone. So don't do that. Alright?
Don't get it backwards.
Yes, it's very important. I even I had STB here, and I took that out so people don't copy and paste it and be like, well, where'd all my home data go? Dan, you ruined my computer. I didn't do anything. So figure out what this one is. You can just do an fdisk-L. I'll show you here.
What's your block size?
What's that? Oh, there.
4 meg. Find it. Yeah. Do it.
How's that? Better?
Make the wiki bigger.
That's wonderful.
That's reflection on
Well, obviously. So, if I do an fdisk-L, you can see that I have, this is on my laptop here. I have my primary device, dev, SCSI disk A, partition 1, device, SCSI disk A, partition 2, SCSI or SATA, they're the same drivers now. And then I have other de-encrypt stuff, so my laptop's encrypted. So this is my encryption device, and then there's some LV under here too. But whenever you plug your key in, and you do an fdisk-L, it'll probably come up as dev-STP or dev-STC. You can also see it in the message queue. So if I plug something in, it should show up here. But that's entirely part of this. So you image it, you use DD or something, and as you can see, I did that right here. So I use time. Time will give me how long it ran, so it did this image in 3 minutes and 19 seconds. I told it the in file was the image, the out file was the device, and BS stands for block size. And so I told it to do a 4 meg block size because I think it defaults to something like 16K. And so it's just sitting there hammering that little SD card, and if you increase the block size, that makes it quite a bit faster. So imaged it, and then the next step is to set up the initial system. So you write that image, I did sync right here. What sync does is it flushes the file system buffers on the system, and it allows you to basically unplug things that are unmounted. And make sure that basically all the writes to the devices that you're encountering are done. Okay. So next thing is the setting up of the initial system. I'm going to hook up the Pi. I'm going to set a user password. I'm going to set a host name. I'm going to start. Who knows what that is? Anybody? Any of the new guys? What? I can't hear you. SSH? Yes. David. There we go. So it's the SSH server, and we're going to update the system. So hook up the Pi. I hooked it up like a regular machine because at this point we don't have SSH going on. We don't have any way of remotely accessing the server, and so we want to put the card in, hook it up to the Pi, hook the Pi up to the monitor, keyboard, and a wireless or a wired Ethernet connection. Now, I'm sure you can do wireless too. But I didn't go into that. So there's one of the tools I'm sure allows you to connect to a wireless access. So the default credentials are Pi and Raspberry for the Raspbian image. What's that? Oh, heck no. And so the first thing we're going to do is change that password. So we log into the Pi. We run sudo raspi config. Now, that runs this utility as root. So let's go ahead and just run that. Nobody's sudo as pi config. This is what you get. Okay? So it's a nice little menu. Allows you to go through and change things. Now, one of the things that's horribly irritating about Raspbian is it's made in the UK. And as much as we love them because they made the Pi and they made the operating system, and those are both really cool, their keyboards are very slightly different than ours. So you can't do tilde or pipe using their key mapping.
Until you change the key map.
Until you change the key mapping. And believe me, because I did not use this config thing when I first was starting to play with Raspbian, pulling my hair out because I'm like finding the file that can do it, and then like I was having problems editing the file because of the key mapping. Also, when you change your password, if you change your password right now, and I said we were going to do that first, and we're not going to do that first. If you change your password right now, it's using the key mapping for the UK. If you then change your key mapping to the US, you can no longer log in. Okay, so that's a very important point.
It's a serious
There you go. There you go. It's a tricky bugger too, because you're like, all right, everything's great, let me restart. That's the password I used. I swear I wrote it down. So what we're going to do is we're going to configure it, then we're going to reboot it, then we're going to change the password. Because we'll have the right key map. All right. So first thing, change locale, which is your key map. You're going to, well, this is actually not the key. This is locale, this is the key mapping, time zone. But I removed ENGB, which is English Great Britain. You don't have to remove it. It is just supplementary at that point. I added ENUS UTF-8 or whatever other language you would like to add. There's a whole barrel list. There's UTF-8, there's IEEEs, there's a bunch of different versions of it. But UTF-8 is kind of the standard that everybody uses. Excuse me. Then you're going to change the time zone. And I wanted to change my time zone to the US Eastern. So that's cool. Now, one thing to know about Raspberry Pi, it does not have a real-time clock. It has battery powered. It doesn't have, I don't think it has a real-time clock at all. That means that one, you get a lot of clock drift because it's software clock. And it's relying on the processor. And the busier the processor is, maybe it's going to miss a clock cycle. And so you'll have drift a lot. And when you turn it on, it thinks it's when the program, or when it thinks it's basically epoch. Alright? And so, that's bad. So you need to set up, if you want time, if you want this thing to do time, you need to set up NTP. I don't really go over that, but I just want to give you guys a heads up. If you keep like, every time I turn this thing on, the battery must be dead because like I get the wrong time. No, it's just because it's incapable of doing it. Did you have a question?
I would like to iterate, that is very important, setting up NTP on the Raspberry Pi.
It depends on what you're trying to do with it, but it really throws you through a loop if you're trying to look at logs and you're like, well, when was 1970?
Exactly.
Well, it's 1970.
Yeah.
And I powered it on.
Yeah.
So let's drop time and do some math.
Yeah.
Or if you can use SSL at all.
Yeah.
Any
So
sort
like
of
any
secure
kind of
communications.
security configurations.
VPNs.
Yeah, there's time is
Crypto
usually very
seems
important.
like
Crypto really likes using.
a lot of developers are lazy to use time as a seed.
Yeah. So if the time seed's always epoch, then that's not great. So what we'll do is we'll change the time zone, which will, that's just the time zone. That's not actually doing anything to the clock. Then we'll set the keyboard layout. Now this is what will really mess with you if you're trying to actually like use it, and it's the Great Britain, and then you change it over to the US or anything like that. So, and it's actually kind of far in there. So you go to localization options, the time zone, Wi-Fi.
Maybe unchained okay.
It's in there somewhere. But this is in that menuing system. You want to change it to the generic 105 international, or it is generic 105 international. You want to change it to generic 104 TPC. And the keyboard layout, you want to switch that from English UK. You then choose other. You then choose English US. You can choose English US again, and then there's no compose key. Depending on your keyboard. And that's all you have to do to change that. Then you can change your Wi-Fi country. Now, I actually believe that this is supposed to be in localization options, but it doesn't seem to be there. So.
Yeah, there's an I3 missing, isn't there?
Yeah, it's supposed to be right here. I'm not going crazy. Alright, I don't know why it's not there. Maybe I did something in a config file that just doesn't like. But yeah, this change keyboard layout is supposed to be right here. That's why I was confused, because this is like, I had this in order. So you would do that through this tool. If this tool isn't here, you can go and change it with the actual config files. Which is if I wanted to change it again, I'd have to change it to the config system.
With the Wi-Fi password,
The Wi-Fi password config file? We'll get to how to configure all the Wi-Fi and stuff too. So that would be the more. This you could do some wireless configuration, I think, but we're not doing that here. Change the Wi-Fi country. You can actually go and change that as well here. And so what this determines is certain countries have additional channels, and you want to choose the U.S. because you want all your clients to be able to connect to it. You don't want to.
You have an extra 3 channels that could be on the US.
Yeah.
It's also illegal.
Yes. So you do all those things, and then if you go to advanced options, you can, one thing I forget to mention, this expand file system, this actually runs on boot. So when you turn the Raspberry Pi on for the first time with its image, it will boot up. It will expand the root file system to encompass the entire card, and then it will reboot. Okay? And then after it reboots, then you can log in. In the advanced options, you can do expand file system. So if you just like pulled your image over to another, all right, I have a 32 gig card. Oh geez, I need to have a 128 gig card. Well, instead of starting over and having that automatic tool go, you just hit this expand file system and it just does it. Overscan is those are video options for the video devices on this. Not really something that we're probably going to need to be playing with on this one. Memory split, I actually changed that. So this is, I have it at 16. And I think the default is 64. And so we don't use the video, so we don't need to change that. Audio, we were talking about things that you could do to reduce your footprint. Turn off the audio. You don't need it. Turn that thing off. Resolution, and these are just like options that you really need to play with at this point with this. Then when you finish, it would post and say, hey, you need to reboot. Do you want to reboot? So yeah. And so you reboot the machine, and it'll come back up, and you use that same password to log into it, that Raspberry, or the Pi and Raspberry. And once you do that, then you rerun the Raspberry Pi config, and I actually have a how to unbreak your device, because I did that. Basically, you shut off the Pi, you pull your SD card out, you plug it into your laptop, you log in, or you mount that file system, you go into the shadow file, and you delete the password out of the shadow file for root. Then you log in as root, and you can do it. So, we're going to do the Raspberry Pi config again, and we're going to just change the password, which is just password Pi, but if you want to, then you run that. and then host name, and that changes to Etsy host name and Etsy host entries. And you're good to go for the initial setup for the Nexus. Now you have the US keyboard and everything's going well. Next, we'll do SSHD. So it's the SSH standard, and I do add on all of mine a special option that is in all of these, but it's usually disabled. And I'll be here in a moment. So first, I usually do things. There's two camps for when you're utilizing a Linux system. There's one camp that says you should do everything that you need to do in an escalated privilege as sudo, and the other camp is, to heck with that, just do it as root. I like doing it as root because I know where I am and I know what I'm doing. A lot of new users may want to use sudo for specific things, but when I'm doing operations that need to be root, I'm going to be running multiple things. I don't want to type sudo every single time I do anything. Alright, so that's why I did sudo-i, which gives you an interactive shell. You can also do su dash or just su dash or su without that. And you can do that but not on this system because root doesn't have password. So, first thing I do, I make a root password. Okay? The reason I do that is if I get locked out, if I accidentally mess up my Pi password or something like that, I can plug this thing in to a device, like a monitor and a keyboard and all that, and then I can log in with root. The reason that this is safe is in my SSHD config. Use your favorite editor. I use Venom, but the first one I exemplified at Nano here. In your SSHD config, there is a line, and that line is permit root login. Tell it no. You don't ever want to have anybody logging into your system as root over wire. Okay? I'll tell you what, I have a couple of servers on the internet. 90% of the login attempts are root. If you just don't ever run on root, you have a problem. They're gonna, like, hey, I got the right password. Doesn't matter, you can't log in. So, not only do you have a password, but you just straight up deny root access from SSH. You can log in directly. Then, because this is a more modern Linux system, we're unfortunately using system D. And so it's systemctl enable SSH, systemctl start SSH. At that point, you can run ifconfig and see what your device's IP address is on the physical LAN, and then SSH to it, which is a great way of actually, like, you can copy and paste into it. It's really nice.
Did the config actually store it on the switch? I thought that switch would really keep.
You can do both. Where's the config? There's IP address. Keeping it alive, man. Keeping it alive. If you do have a system that has only IP, you can actually install NetTools, and that will provide you with the ifconfig interface.
Forever being green.
Yes. Because of old crusty bastards like us. So,
Ain't broke.
yeah, exactly. I don't know, like this whole system blueprint, but we're not getting done.
It's time for another one of those
Yeah,
presentations.
that's a whole other presentation.
Rant.
Rants, yeah. Alright, so then you SSH to it, you SSH pi at the address. Don't just SSH to the address, because if you do, it doesn't have Dan. It's going to be like, I don't get it, that's not the right password. I'm trying to log in as the wrong user. You can also do SSH address-l pi, which would log you in as the pi. And I didn't actually just put the output of it, but you can see right here, I have LO, F0, WLAN 0, WLAN 1, bro. Bridge 0. That is because I did this. Your first run of this, you're going to have a device that's literally 18 characters long, and it's garbage. And what it is, I don't think it's 18, it's like 12 characters, it's very long. What it is it's, I believe, EN, and then MAC address because it's the new predictable device naming schemas. And by predictable, they mean safe. And so that's what you get. I prefer having F0, WLAN0, and stuff like that. Those are static because of UDEV. UDEV maps their MAC address and maps it specifically to an Ethernet name. And you can change those names too if you want. But I wanted to just have the system figure it out on its own, so I told System D, and I had to figure it out. I had to put it this way. I told System D I had to make this link, and this is the way System D tells you to do it. You link a symbolic link to dev null into this file. And this file existing tells System D, hey, knock off that crazy stuff, just put it in the old link. Right? And so you touch that file basically, and you reboot, and all of a sudden now you have your prettier names, pretty much is what it comes down to. And then upgrade your system. Upgrade your system all the time. You should never not upgrade your system. This is how people get hacked. That's the real way people get hacked. Oh yeah, they broke it. No, you just didn't update your system for 2 years, and they used a bug. So, do that. Do that at every opportunity. In fact, just make a cron job that just, or like a shutdown script that every time you try to shut down your Pi, it tries to go out to the internet and update itself. So, next is setting up WPA supplicant. WPA supplicant is what is going to provide us with our linkage to the internet. This is what's configuring the onboard wireless LAN to connect to the access point. Okay, now, there's other ways of doing this, but since I'm building it for static places, I know exactly where I'm going, I know the password and all that kind of stuff. I can literally just make a file, turn this thing on, and as soon as it sees one of the access points it recognizes, it connects to it. Okay? So that's what we're doing here. We're going to be doing things with WPA supplicant and wireless tools. These are our two packages. Now these come installed on Raspbian by default. But I went ahead and put those in there in case you're building your own system that's not based off of Raspbian, like a Debian system or maybe a Jitsi system or something. You'll probably have to figure out the different package names, but that's what we're kind of going for. Wireless tools provides you things like IWList. IWList is fantastic. So like if I do that here, IWList, you can see that it gives you a whole ton of information about it. Now, since I am connected, I'm spawning an access point on one, and I'm connecting using another one. It's only showing me the one cell. Okay? So if I did this before I did all this other work, I would actually get a lot more results. So if I did that for SSID, you can see that I have to go around guessing. Now, if you just go somewhere and you're not associated and you run that command, you'll see all of the networks just hanging out. So it just does a quick look so you can see what's in the area. Next, we're going to configure the WPA supplicant. On WPA supplicant, what you'll do is you run this command, this WPA passphrase, and the name of the access point. You have to put the name of the access point in for two reasons. One, WPA supplicant has to know what it's trying to connect to. And two, that's actually the seed, that's the salt to the encryption of the access point. So if you guys don't know this, and I don't think a lot of people do, it's very interesting. Make your access point name unique. Don't ever let it be Xfinity Wi-Fi, unless you're trying to, man the middle here. Don't ever let it be a standard default like Linksys or anything like that. That's actually why a lot of them have started making like, 2-wire underscore number. Because that makes them different, makes them more. Because this is the salt to the encryption, if you have, for instance, Linksys, and I want to break into your access point, all I have to do is make a rainbow table of all the potential hashes to Linksys. Then I can walk up to your house or your place of business, sit down with my laptop, hit go, 3 seconds later have your password.
Interesting side note on that. There is a project, Church of the Wi-Fi, they've taken, there's a site where people upload board driving data, and they data mined it, found the top 1,000 access point, most common access point names, and created rainbow tables for all.
It's within a certain number of characters. What's the top character limit? It's like 32 characters or something?
No, that's a dictionary. It's based off of pretty much like a Rocky or something like that.
I thought they had a brute force too.
No, but it's, either way, it's pretty strong password. It's going to take little to no time to run it. You just feed it through CalPatty. That's what's out there. So if you have a very common SSID name, then there's a rainbow table for it.
So it's a good point to do this, not only for this project, but for your house and for your business.
And again, this goes back to the NTP thing, make sure that's working.
It's, time is important for encryption. And I can add an NTP section to this as well.
It's actually pretty straightforward on the ISC system.
They actually might be able to.
Sudo apt-get update, sudo apt-get install, NTP. And Debian ships with their own NTP pool configured tool as well.
I remember that. Probably understand. I probably should have started. So what you'll get is you'll get this little block. Well, you run this, and then it says reading passphrase from standard in. What that does is it doesn't actually display the password. I'm sorry, it does display the password, so it will show it, but it does not show up in your history. Okay? So you type in your password for your access point, and then it sets out this. Now, this file, I actually go in and delete this line, because you can, the PSK is the private shared key. Okay? And you can either put it in clear text, or you can have it encrypted. Okay? What this tool does is it builds that encrypted password. It takes the salt, the password, sticks them together, and makes your encrypted passphrase. Then it'll have your password here in clear text. So when you put this into the configuration file, I actually get rid of the password, unless I don't care. But if somebody compromises your system, it makes it more difficult for them to just know your password. They
You can actually just use PSK.
Right, you can just, well, yeah, we can just use that. But at least you won't have to.
You can't really reuse the password if you use it somewhere else. You
Right.
should not be doing it.
No, never reuse your password, especially for this. Because you can still figure it out. It takes a while.
You can brute force it with John, or, like I said, just use it.
Yeah.
It depends on whether or not you care what the password is. It's going to have to pass the hash tags.
Right.
I don't have to know what your password is, as long as I got the hash and the password as good as the password to me.
So what you can then do is take that output and put it into your NC WPA-supplicant.com file. What this will do is, and I added a couple more lines in there, but I say country US control interface directory, and I borrow around WPA-supplicant group netdev, update config 1. These are all just default options more or less. And then you have your list of networks, so you can put 100 networks in there. We have like a whole bunch of different ones that we try to connect to, because we're walking around with this thing. So like I have, in mine, I got kickbacks, and I have this place, I have a house. So like I have a couple of different places, and they're all in that configuration file. So whenever I power this thing up, it just looks for one of those, finds one, and then it finds ultimate, finds the strongest one, and then jumps to log in. So it's just like having, your network manager, but automated. So it's nice. So you set all these things up, and you're automating them. Then you need to set up your Debian interfaces file. The Debian interfaces file, you're telling it, I want you to allow hot plug WAN 0, so you want to automatically bring up if it's there. I want you to use DHCP. It's an INET device, an internet device. I want you to use DHCP. And then for your configuration, because you could actually do some of the configuration in this Etsy network interfaces file. For the configuration, you could do this. And so instead of specifying each and every one of the access points in this file, you just point it at the WPA configuration, and it takes all of its configuration from there. Then you restart your system, and it should just come up on the WLAN 0. That's great. I do want to mention that I had to restart the system, because I did try to bring it up manually. I tried to restart the network infrastructure. I tried to bring up WLAN 0 on its own, manually, using the scripts, using manual things. It would not work. And it's just some PFM that systemd is doing. And so fully restarting the system is the only way I can get it to work. I don't know why. It should work without me having to do that. But sometimes there's PFM with systemd. And so I had to do it. Now, the next section. So now we have the Pi connected to the internet. Great. All right. Now we have a computer. Because we're on the internet. Now we will build a local access point in the bridge. That's where you're spawning an access point using one of these devices. And then also allowing it to be connected to this. For this case, what we're going to be doing is basically building an interface that is the other two interfaces. It's a bridge. That's the grow. We need to install the host AP and the bridge utils. This is actually the first time we've had to install something specifically to deal with something that this distribution doesn't have, just sitting in it around. So we'll do apt install host APD and bridge utils. Right? Host APD is what allows you to spawn an access point. Bridge utils is what allows you to build the bridge. Right? The bridge is just two devices teamed together to be addressed by the same interface. Okay. So setting up host APD, I actually set this one up. This is just an open access point, but so I actually modified it. So later on, I tested it out and this works. So this is the same thing as that, except I added these 4 lines. And what this thing allows you to do is, this would be an open access point. So if you wanted to bring it to the line, or you just want anybody to connect it, you don't want to deal with keys or load from it or anything like that, boom, that creates you an access point that has no logon information whatsoever. Just boom, connects to it. Right? A lot of problems with that. 1, anybody can connect to it. 2, it's not encrypted. So let's say that I gave you all a key. All of you would be able to see what the traffic is. But Bob on the other side of the wall with that key, he wouldn't know how all that traffic would be encrypted. So between you and this, if it's an open access point between this and the world, they can still see it. So just be careful. But this will create you an open access point. If you add these 4 lines, WPA equals 2, WPA queue management equals WPA-PSK, RSN pairwise equals CCNP, and then a passphrase, WPA passphrase equals something. That will enable the WPA2 access point. Right? So you just add those 4 lines and now you're correct. Probably if you're going to be using this for personal effects, do that. If you're going to be using this for like, a group or something, really do it. It's kind of up to you. Then over here, we actually have to set up the defaults because host APD doesn't use that configuration file per default in Debian. And so if you edit this etc default host APD and you add the line dame config etc host APD hostapd.com, whenever you bring up host APD, it'll come up and it'll use that configuration. That was biting me in the face for a couple of days, or not a couple of days. thing not, like I can run it and specify the configuration file, and it's fine, and this is where it says it's a configuration file supposed to be, but when you run it without any arguments, it just, it's just like, here's the default. What? No. That's because of this thing. So, save you some time. Now you want services to set up, sort of include as well. So you do your system control enable post-APD. Right? That's going to provide you with a post-APD system coming out. Right? You want that because this is a portable route. You want that to come out. Now setting up the bridge. You don't have to do this. This is kind of an option. If you're making a Raspberry Pi that's basically one wireless to a second wireless, and you don't want to have Ethernet or one wireless to one Ethernet, you don't need to do this. Because this, we're basically allowing it to be multiple interfaces to one interface. We're going to edit MC network interfaces. Now, before I actually thought that you had to put the address broadcast message gateway for each one of these things, but then I eventually tested it, and you don't. That's great. So I say auto F0, which is my physical device. Auto F1, which is my little dongle here. And I told them both to be manual. Okay, so they're manually configured. Alright. Then I say auto DR0, or bridge. I tell it I want the interface DR0 to be an internet device, and I want it to be statically assigned. Okay. That static assignment is 10.10.10.1. The broadcast address is 10.10.10.255, and that matches the /24, which is 255.255.255.0. And then my gateway is, again, 10.10.10.1, because this is the internal. If you go ahead and reboot it, then you can see I'm using IP address here, or IP adder, which is your system D upgrade. It's IP route 2, not system D. Good call. Sorry about it. Talk to you later. I use IP adder, and I can see all the devices. Now the devices are LO, which is the local device. F0, which is my physical device. WLAN 0, which is my primary wireless device.
Sorry.
Plug-in.
Oh, God. I just got
I'm cutting off half of my window here.
Wobbly windows.
down or up.
This way. There you go. There you go. Good. All right. This is your physical device inside of the board. This is your external device here, and this is your bridge. Now you notice that the bridge is actually the only one that has my IP address here, so 10.10.10.1. If you look at WLAN 1, it doesn't have IP address information. If you look at F0, it does not have IP address information as well.
Sorry, I just got called into work
Oh,
because every switch in the entire stadium just went offline. So I'm gonna go follow.
Need a fire extinguisher?
Hopefully not. Like I don't know yet. All voice and internet are down, so I have to go. Follow us on Facebook. Like us on Facebook. Follow us on Twitter. IRC website. Have fun.
see ya. Good luck. So, now that we have our interfaces all sorted out, now we want to build our services. One of the very essential services in a router is DHCP and DNS. So, this section I'm covering DNS mask, setting up local resolutions for DNS, and this is a really good one, setting up Stephen Black's host. I'll get to what that is. So DNS mask setup. DNS mask is a great utility that allows you to build a DHCP and DNS server all on one shot. Okay, so it handles both your DHCP and your DNS things for your clients and clients now. So again, this is a service that is not on this distribution, so we want an app to install DNS mask. And there's a couple of things in the configuration that we want to see. could put a lot more into it if you start putting in things like resolutions for a boot server. You can do things like that here. You can assign a boot server. And this could be the boot server. So if you plug a computer into it and you tell it, hey, boot off the network, picks a boot server, then you can boot off of this machine and like provide it with an image. So that would be great for like Linux land parties. Where they're like, hey, you want to try out Linux? Boot from the network, tell it to boot from the Linux image or the Mint image. It boots up Mint, and then it can sit there and play around with it without ever even having to plug in anything or anything. We'll just plug it in the network and start using it. It's great. So there's a couple options here. DHCP authoritative. What DHCP authoritative does is it says, I am the master. There can be multiple DHCP servers on the network. If one of them is authoritative, then if my client is provided, I call out and I say, I want a DHCP release. The client sends that out to the network, sends it out to broadcast. There's 3 DHCP servers that respond. One of them is authoritative. Okay, let's say number 3 is authoritative. So one gives me an IP address. I say, yeah, thanks. And I apply it. 2 gives me an IP address. I say, I already have one, sorry. 3 gives you an IP address. He's authoritative. I say, oh, you're the master. And it dumps the IP address I got from 1 and you post it on the IP. So that's a very important point. Also, if you want to screw up somebody's network, you plug somebody DHCP authoritative and throw them off. And give everybody a 48-hour lease that doesn't go. Don't do it.
I did that accidentally once.
Yes, I have also. It's a very, very interesting time talking to network admins. Pesky interface thing. Sometimes you can switch around. DHCP range. What the DHCP range does is it gives you a range and a time. So I told it I want my DHCP range from 10, 10, 10, 100 to 10, 10, 10, 230. So I have allocated 130 addresses for that space. Now I don't think that this thing could handle anywhere near 130 clients. But that's what I chose for my range. You can put the range wherever. What's advantageous about doing something like this is you can statically assign other addresses, and you can do that in this, or just like providing others. And you can like leave yourself basically a dead zone of IP address space that you say, okay, so my router is at 1, my broadcast is at 255, my automatic addressing is 100 to 230, but from 20 to 70, those are my static addresses. And I just assign servers to that, and I just know people will mess with them with the DHCP server. Okay? Then the interface is obviously where it's broadcasting to. You wouldn't want to put this on W0 because it would encounter the problem that we were just talking about. We're just broadcasting DHCP leases to the network that you're on, and that's not cool. So you end up with something that looks like this. You have interface, DHCP range, and then if you want, DHCP authoritative. Okay?
You have to make sure that you're not crossing into the next hop, right?
Yeah, that was the wireless line 0 thing. The wireless line 0 is the other network that you're connecting to.
Right.
DHCP,
But no, actually, it's that 0 is using 192.168.
Right, I know what you're talking about. So let's say that it's 10.0.0.0/24 on your host network, and then you assign 10.0.0.0/24 on your restaurant network. I believe it will work for routing protocols. It will probably work for anybody that's not sharing an IP, but the router may get confused if you're.
You got you and other people share the same.
Let's go ahead. You're going to have some problems. I'm not sure how it would react in that specific case. That's a good question, especially when you're dealing with something like this. That's why I actually chose 10, 10, 10, 0, because that's a very lightly used addressing. You can also do something very strange, 10, 15, 20, or something like that. What's that?
What was the 169 different?
You can address anything you want in your internal. You're not supposed to. But you can. So I would go like 172 is an address that That's the network address translation table. And so, in our example right here, so I have 192.168.200. That is my local address given to me by phone. Right? If I was external, like if this was giving me an external address, I would not have it because I'm just going straight outside. What we're doing here is a double map. So GoRack has an external address. They go through a network address translation table and provide internal IPs for the internal space. Then my box picks up one of those internal IPs, builds a network address table, and builds its own internal IP structure. Generally, when you're dealing with something like that, you don't want conflicts. So, very good point to have not having that conflict in there, but that's also why I did the 10.10.10.0, because it's very odd number for usage. Most people have 10.0.0.0 or 10.1.0 something or 192.168.something. So you don't want to do like 192.168.16. What's the really common use one? 192.168.1 something. Yeah, or 0. And so you wouldn't want to put your internal addresses on the portal in that range. But if you're having problems, you're spinning up an SSH server on this and you're building an internal network. So the internal network will not be affected by duplication like that. And so if you're having a problem, just take your laptop, SSH into the box, and check it. And see if it's a problem, and then reconfigure it. If it is, restart the by it, and we should do it. So there's ways around it, and that's one of the main reasons to turn on SSH instead of remotely administer it. When you're sitting in your laptop, you don't have like a TV and a keyboard that's kind of floating around. So very good point. Awesome. So you don't want that. So next is the local DNS resolutions and Stephen Black's files. Stephen Black's host file is a great little, it's a GitHub project. And what they have, what this guy's made is he has taken lists and compiled them into these giant lists of host files. The host file is going to say 0.0.0.0 and then a name of it, an address. Okay? So the way DNS works very simply is you ask a DNS server, what's google.com? The DNS server replies with, it's 8.8.8.8. We're the man in the middle with this. So, this device, when I say what's google.com, I can tell them it's 0.0.0.0. Okay? I can tell them whatever it is, whatever I want. Ads, malware, viruses, most of these things use DNS as their either command and control or as their attack. So you go to google.com. Let's say you go to Yahoo. They got ads all over there. You go to yahoo.com, and there's a whole bunch of ads. Well, those ads aren't hosted by Yahoo. Those ads are hosted by Google AdSense and Shady RU and all these different places. Right? This host file has all of those ad URLs, all the known ad URLs, all of the malware URLs that they know, all the virus URLs they know about, things that are like command control and stuff. And it's just a giant list of new. And so it's 0000 Google AdSense, 0000 shadysite.ru, so on and so forth. Giant list of them. And what you're doing is you're nulling out all of those values. So whenever I try to go somewhere and it tries to serve me an ad or serve me a piece of malware or I have a virus that's trying to reach out to command control nodes or anything like that, it stops here. And that's great. So And then the reason that a lot of the malware people, a lot of virus people have to use DNS is because a lot of times their IP ranges get blacklisted or blocked. So they have to hop around, they have to move around. And so you have that kind of issue. So this is preventing that. And it also gives you the benefit of the DNS mask allows you to build a local address. Okay, so it's, you want to have your box name something, you want to have a server address or something, you can have it. So here, what I did is this is a little script that I wrote, and what I do is I have this run whenever the machine comes up. I tell it, go to the internet, go to raw.githubuserscontent.com/StephenBlack/host/master, which is this alternatives, fake news, hosts. And he has a whole bunch of different ones. There's ones that have ads, there's ones that have malware, there's ones that have viruses, there's ones that have porn, there's ones that have fake news, there's a bunch of different ones. And so I think I chose the most restrictive one, and then I output it to this file, root blackhost. Then I took this root host.local, which is a file that I made, that just had the contents of the Etsy host file, and then any entries that I wanted to put in there. And what I do is I say, all right, I'm going to cat that into this file, but I'm going to single redirect. Single redirect overwrites any contents that were previously in that file. So I'm going to take this, which is my manual file, this is the stuff I want to have personally, and I drop that right in there. Then I cat the root blackhost, which we grabbed up here, and I append it, which is this double, to that same file. So now I have a big file that has all of the entries that I care about at the top, and all of the other stuff at the bottom. So all that garbage reduction at the bottom. Then I copy that root host to Etsy host, and then chmod it to the proper value. So it's read, read and execute, read, Etsy host. And then I restart DNS mask. Right, so every time the machine boots, it gets a fresh copy of that band list, and then puts my local thing in there. And then anytime I want to change my local thing, all I do is just run that script. So,
I got a question for you.
yes.
Does it work with a VPN? You route through a VPN?
This is blocking DNS. So if your machine tries to grab a DNS address for anything like shadysite.ru, this machine is your DNS server.
But if I want to use the VPN?
Well, we don't actually cover that in this presentation for the VPN. The VPN would be on this hub. So that if you put a VPN on this machine and you're routing through that, the services on this one don't matter. Depending on how you have your VPN set up. If you put the VPN on this machine, then this affects it. Because your machine is going to, it doesn't even know about the VPN. So it goes to this machine that says, I want the DNS address for whatever. And if it's one of the banned ones, it's provided a DNS address. It says the DNS address is 0.0.0.0, which is local. Yeah, it's unaddressable. And then it just doesn't go. So you can do that in different areas, and I will cover it in another time, because I mean, one pretty long in the tooth, start to lose the course of it. But I didn't get to doing the VPN stuff in this presentation. So maybe one of the CLCs will go over how to build a VPN to a router. And that way, all of your traffic from all of your machines goes to that VPN router, and that exit the node way out wherever. So that's definitely coming up.
Can you show us the contents of the host file?
Which one?
The contents of your Etsy host?
Huge. Oh yeah, I'll show you that in a second. This is the cron tab that I had for root. And so I say at reboot, so as soon as the box reboots, I tell it to sleep for 30 seconds. What that does is I'm waiting for the network and the box and everything to settle down. I want to make sure that I have a solid connection to the internet and stuff. run that host gem.sh that goes and grabs the file and makes everything. So yeah, let's take a look. That is my normal host. For some reason I don't have the files here.
Breaks through everything.
No worries.
Copy it. This is how it set it up anyway. So I copy it goes to this file. Alright, so now I have that post.local. Alright, then I run this host gem. See, it goes out, grabs that file, and it combines everything, and restarts TOS mask, and if it had, it's in host somewhere. You saw how short it was before. Pages and pages and pages and stuff. So like, Mr. Newswatch, MSNBC.website, .hotdaily, nationalreport.net. I think they actually have our them set up by section or type. So, yeah, so there's a lot.
So
There's all your ads, so add stuff, whatever.
Is it your NCNS switch electron file that's pointing to hosts first?
The DNS switch defines that it's pointing at hosts and then DNS. But that's not what's controlling this. So DNS mask uses the host file to define what it's providing with clients. So the host file will be local resolutions. So what you're doing is you're telling DNS mask, you're a bounce target. So all of my clients go to DNS mask for their DHCP and their DNS entry. Whenever I look something up, it goes to my laptop, goes to the Raspberry Pi, asks DNS mask, what is this address? DNS mask, by default, will say, I don't know, and it then forwards its request to the next hop up, which then forwards it to the next hop up, and so on and so forth. What we're doing is we're stopping that right up front. We're saying, you know what this is. It's just that the resolution is 0. So it is just,
So DNS mask is synonymous to name D or something.
it's like name D and DHCPD put together. Simple. It's very simple to set up. It's very easy to deal with. There's a lot more options with name and with DNS or DHCPD. You do all that stuff. I like DNS mask for this for some. It's very easy to set up, especially for home users. If you're running a business or college campus or something, probably wouldn't want to use DNS mask because it might not be load, you can't do a lot of interesting load balance and things or like failovers and stuff that the other products can't do. So it's kind of the home block versus the home block. So next, try to finish up pretty quickly. We've gone over IP tables before. This is just a real simple setup of it. What we want to do is there's a couple of things we need to change up. We need to turn on IPv4, and that's allowing the kernel to move packets from one place to another. We do that we can do that temporarily and permanently. The temporary is this first window, so you echo 1 into proc sysnet IPv4 IP4. By default, that's 0. This will immediately turn on the IP4 function inside the kernel because you're editing. These are the kernel sections right here. Right here, syscontrol.conf for Debian at least. Most all Linuxes have something that resembles this. They just may not be the same things. So etc syscontrol.conf is there's a line in there, and all you have to do is uncomment this to net.ipv4.ip4 equals 1, and on boot firewall. This prevents people from going to ports you don't want, or all kind of stuff. But I just did a very simple one here, and I show you how to prevent somebody from accessing another one. So here I used if pre-up D IP tables, but you can put them, there's a bunch of different ways of re-associating this stuff. But here, what I did is I said, all right, I want NSH to run IP tables restore and grab this IP tables, Etsy IP tables rules, and put that into this file. And so when the network comes up, the if pre-up D, it will run this command. And what that does is it runs IP tables restore, and it takes the IP tables up rules, which will write in a little while, and it crams that and replaces the IP table rules that are coming up with the system. All right, and then I make that executable so that I can run on through. Then, when you're building your IP tables, you can just build them and then save them. So you can build them live, figure out exactly what you want, and then save them off. And there's other ways of doing this too. There's simple IP tables, there's simple firewall, it's like U firewall. What is that? Yeah, UFW is something else you can do it with, but this I'm just using a couple tables. So IP tables -TNAT-A post routing -W or -OWN0-chain masquerade. What this does is it tells the NAT table in the post routing part of the NAT table that I want to masquerade things going out of WLAN 0. Okay, so I want you to act like you're the origin for things that are leaving WLAN 0. So my box comes into the WLAN 1, routed through the kernel, and then out WLAN 0. That's what the masquerade is. Then, if you want, that's basically the core of the router right there. You have your DHCP, your DNS, and then that. And that's pretty much it. Then if you wanted to restrict networks, so like if there was a network that was 10.1.10.1, but I didn't want my people to access, so let's say I was at the security group, and we had some people that were, wanting to poke at stuff, and I didn't want them to access the internal corporate network of our host, then I could tell my router to just explicitly drop or reject packets that were destined to that interface. And I can drill this all the way down to where it's coming from, where it's going to, and this is a very simple example of that. And so I tell it, I want to go to the output table, I want you to accept where the destination is this, which would be probably the router, but then I want you to tell the output to drop everything that goes to anything else. And it goes in order. And so the output table, I would say except for this address and then drop everything else. It's going to, anything that goes to that router will be fine. And then if it's not that router, then it drops down to the next line and says, oh, you're going to go to .3. Sorry, it just drops it. Same thing here. Input table, I want you to accept from this address. I want you to reject everybody else. Now the difference between reject and drop, reject, you get a packet, it sends a packet back saying, sorry, I'm not talking to you. Drop, you get a packet, it just drops it. Very nice. So if somebody on that network wants to talk to me explicitly, I just say no. I literally go back to them and say, don't talk to me. So that's what that kind of does. So you're kind of restricting what's going on. So you would prevent somebody from attacking you with this, and you prevent somebody from attacking them with that. Order is extremely important because it walks down the tables. It walks down. And when you do an IP tables -L, and you look at that, it starts from the top and moves down to the bottom. So if you have an accept all, and then you have a drop all, everything's accepted. If you have a drop all, and then an accept all, everything's dropped. Yeah. So, and you can do that. This lets you do whatever you want. Right. Then I'm going to run IP table save. After I've done all IP tables, you can certainly do more or less or whatever you want. You just need the masquerade one, please. And you cap that, it gives you this. Now, it looks a lot different than the picture we're running. That's only because it's sectioning things, and so this is a table, and then this is the rule. Okay, so there's tables of rules. So the output table, the default action is accept, and I say for the input of that table, when its destination is this, I want you to accept, and then the input when the destination is that, I want you to reject with that. I see the keyboard original. Okay. And you can customize all that. And so this is your IP table. and we want to stick it in, and iptables-l will show you live, like this is what your system looks like right now. And it has all your chains, and you have to do -t-nat to show the NAT tables as well. That shows you those as well. You stick all that into that file that we were talking about earlier. That's the iptables.rules, and with that script, pops it in. iptables.rules is read, and then it overwrites anything that was there previously. All right. I haven't done this section yet, but it's very simple. Keep your system up to date. Back your system up. This is an SD card, so I'm going to go through a lot of thing to have a file system on it. Take an image of it once in a while. Roll rep. Like a DD, you take an image, so use DD to take the image, but then Jesus, because this is a 32 gig SD card. I probably have 500 megs or less of information on it. If I take an image of the 32 gig SD card, it's going to be a 32 gig image. Pretty big. Gzip it, or just like, zip it, do lazy, like LZ or mag, something really trivial, and it'll go from 32 gigs to 500 meg or less.
I'm going to point out, you can actually set it up for USB, but you also use a flash drive to bypass some.
But the flash drive had the same problem.
SD cards really,
So, sorry for kind of dragging on a little bit, but are there any questions?
Well, I just want to say this. Thank you for doing this presentation. Now I know exactly what I want to do with my Raspberry Pi back in home.
Cool. We'll help you have fun. Email a list or jump on the IRC server if you have any questions. Okay.
I noticed that, put it this way, what you're doing in there, if I had, you said I wanted to do a new install on me, I did exactly the same thing to lock down my knee. So,
Well, I mean, this is starting from a very bare bones, and working our way up.
but I guess what I'm saying, there's a certain point you're doing Pi, and when you go into the regular, make sure that nothing gets in your machine kind of security, really. So it's kind of like making this Pi secure, but you can use the same information to, if you're installing the,
Okay, so this is your host file. What's that?
You can use that host file, right?
yeah.
Yeah, the Black's host file, you can definitely use that on any system.
So,
It's fantastic.
so what I'm saying is, kind of like, for me, I'm getting two things out of one, how to make the Pi router, but also how to work on my other machine. And then the other thing is, I'm thinking of the desktop group, we'll get people that we're assuming are clueless. I mean, yeah, we can install whatever we want on there, but we haven't really secured it. And they're the ones that need security most because they're going to shoot themselves in the foot.
Yeah.
So this is very important.
In the Black's host section, that specific section, if you just grab that once and stick it into their host file, at the bottom of their host file, it's fantastic. Even if you don't get the newer stuff, it still cuts out all of the stuff that's just kind of around that they're always using. And the thing is it will block ads. And there are a lot of things that don't look like ads, but they are.
Now, is that, when you go to a site that says, oh, you're using an ad blocker, it's circumvents that, doesn't it?
Yes and no, it depends on how the site does it. But what really comes down to is, like, let's say you go to Amazon, and you see, and they're doing some kind of like machine learning to figure out what you want.
Yeah.
And they do that. Like all these companies do. And they show you something that you want. You click on that, it will not work with this file. So you click it, it's just it dies. It just explodes. Yeah. So
you do for search results, usually like show you stores. So like say you're looking to actually buy a product and you search for it, it comes up and you can't click it.
Yeah.
So that
It's a very important
4 days
point.
later, you're looking at something else and the ad pops up for that thing you were looking at. It's like, I already bought the thing, I don't need to see it.
But I'm mentioning that because it may look like to an inexperienced user that you've broken the system.
Yeah, right.
Because it says, oh, I can't get to this thing, and I try to click on it. You're like, well, it's an ad. Like, what do I want to click on?
Yeah, well, the thing with computers, what I learned, especially from my point of view with new people, is that it's not like a toaster. You don't push one button and it pops. in there, and you have to understand, if you push this button, it's gonna burn your toes. So, that's my mentality towards it, so, but, it's just, we got a lot of great toys, but they are not so simple that they can claim it is, I mean, advertising. Oh, yeah. Just like the videos, I want you to watch videos on your phone. Well, the videos, there's no time to eat up all your data.
Yeah.
So, what's the point of it? It's like, one guy saying, oh yeah, you know what you want, the other guy saying, oh, by the way, you got to pay for it.
So,
Yeah, so it's,
one of the things I'm trying to do with this, so what I'm trying to do with this, I'd like to actually bring it to your group, or
Yeah.
have it at our local ones.
yeah,
I can bring this thing to the group, set it down on the table, we can have people plug into it, I can build a boot server, a Pixie boot server,
Right.
they can plug it in, and then Pixie boot from this, and it gives them a menu. Would you like to try that? Would you like to try that? Would you like to try Ubuntu? Would you like to try blah, 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 blah?
And they can do it
And
right
it's
on
just
that.
got all of these different versions of Linux, and like a rescue thing too, if they mess up stuff. And you just boot to it, it moves right off the network, and you don't have to have keys and try to like put images up, it just, you set it down, it works.
remember you told me before you were getting excited, you got me excited.
It's fun, it's a great game. So, any other questions? Listen,
The IP tables, is that protocol specific? Like, is it just for?
it's for anything that the kernel handles. So it's different protocols. You can specify TCP, you can specify UDP, you can specify NX, you can specify all the different protocols inside of this. I don't do protocol specification in my example here, but if you're doing like port forwarding or anything like that, you would be saying, I want to forward this UDP port to that UDP port for this. So, yes, it is specific to it. Any more questions?
Are we doing lunch?
We will do lunch.
Yes, I just sent Gene, I think, saying burger fly 15 minutes ago.
Is the user going to go to the 4 error on that or something?
It would have room if they were to it wouldn't get a 4 because a 4 is a response from the server. It would just say, this is an invalid, this is an invalid place.
A small part.
I tried to decide it's going to be
Figure it out.
or less, but I mean, you migrate out or something.